As we discussed last week, we were talking about arithmetic progression. Okay, this is an overview of what we discussed. Okay, so we have done this in our previous episode. Today, we're going to talk about geometric progression and how is it done. Okay, so let's dive right into it. Okay, so geometric progression here. First, you need to take note is your common ratio. Okay, your common ratio here. So how do we understand them? How do we identify them? Very simple. If you can see here, this in this equation here is following the sequence as per usual: T1, T2, T3, T4, okay, and so on. Okay, so common ratio meaning is Tn over Tn minus 1. With that said, if you notice for this one is T2 over T1. This guy here is T3 over T2. And whereas this one here, lastly, is T4 over T3, as per usual. So it's just a sequence of division or common ratio. Okay, so if you notice here, the first one, the common ratio is the same. It's all of them are 3. As you can see, it's evident here. It's the common ratio. But if you notice in the second equation here, it looks like, okay, 0 0.1, 0 0.2, 0 0.3, meaning the ratio here is calculated 2 and then the next one is 3 over 2. Hence, this is not a common ratio. So if you identify it, geometric progression is all about division, okay, and multiplication. Okay, meaning if you just to understand it clearly, okay, let me just put it very clearly. The difference between the terms is either being put through division or multiplication. Hence, it's known as geometric progression. Whereas the arithmetic, as we discussed in the last episode, is talking about just common difference. That means it's either sum or addition. Addition or subtraction. Yeah. Okay, so let's go to the next one. So this is where the term is being calculated. So this is the star of the show. Okay, so A, R, N minus 1. As we have discussed in the previous episode, A is known as the common term. And previously, earlier, I've discussed about the common ratio as well. And the N, as you can see, is a sequence. So the sequence of starts with 1, 2, 3, and so on. So if you look at the question here, find the common ratio at the 5th term. So hence in this question here, they want is N equals to 5. So you just have to put it into the formula and get the answer. Same goes for part B. If you notice the same thing, they want 7 terms. So hence, if you notice N is equals to 7, you calculate them and you get the answer. It's as simple as that. You may wonder why is this equation not being discussed? This is very rare equation. So if you have any questions that you want to ask about this formula, please do so. I would love to discuss them with you. Okay? Here. Next thing is, this is the most common equation. First, you notice that there is 2 famous equations here, but they if you notice by just a first glance, looks the same. But take note of the arrangement of 1 minus r and r minus 1. Same goes in the top bracket as well. Why is there a difference? Why is there a switch of place? It's very simple. It's when an r is less than 1 or when an r is more than 1. It's as simple as that. So if you look at this sequence here, okay, they gave you a geometric series 1 plus 5 and so on. Find the sum. So because they want to know until the end how much is the sum, right? So the sum of the first 10 term, you need to first identify what's the common ratio. And you notice the common ratio here is 5. Meaning this 5 divided by 1 is 5. Or if you look at 25 divided by 5, it's also 5. Anyway, so this is our common ratio. Our A, our first term is 1. And then when you plug it into the formula, please identify R is equals to 5, right? Which is more than 1. Hence, you take the first equation here. You substitute them, you get the final answer. Sum to the nth term, which is N in this case here for part A, N is equals to 10. Okay, for part B here, they already gave you the sum. Okay, they gave you the sum. Now, the question is they're asking you what is the value of N? So what's the N term here? So very simply said, just have a look in the equations. You just plug it then accordingly with the A and everything. You plug it into them, then you solve it like algebra. And of course, there will be a blend of logarithm here. And how do you solve them? You can visit my playlist. Okay, I have an episode for it dedicated for logarithm and all that. You can understand them there. Okay, now the next thing is sum to infinity. So that means they want to know where it ends. Okay, how much is the value? So this only applies when the r is less than 1. Okay, so when r is more than 1, this formula does not apply. So please do not do and or solve any equation if the r is more than 1 and then you use sum to infinity here. So as you can see, there's no n because the n here is already approaching infinity. So if you see the equation, as per usual, when you substitute them, you get the answer accordingly, and it's quite easy as well. Okay, so now this is a very common question, and this is where it happens a lot because sum to infinity for a decimal repetition. Okay, so if you look at this equation here, the decimal repetition starts at 6 and 3. 6 and 3. Okay, so it's usually we'll do a repetition 63, 63, 63. If you notice, the 63 is occurring, but the decimal place is increasing. Okay, but the 0.5 here is the first term. Why? Because this guy here does not apply to this equation. So you just take him out. You look at this as a geometric progression. So as you can see here, this is your first term. Your R is as per usual 0.00063 divided by 0.063, and you'll observe there's a value of 0.01 being obtained. Now you just plug it in into the formula here. This is where the sum to infinity occurs. This guy here, as I say, you've taken it out, so you don't talk about them. Then you solve it, and then finally your answer is here. So please be very careful. Sometimes in the exam, they'll play with you with this. They'll add in one dummy value here where you have to take out, but you don't, and end up screwing it up all over. Okay, so now this is the end of our arithmetic progression and geometric progression topic. So I'll see you guys next week with a new installation and a new chapter. So please stay tuned. So you guys have a good day. Stay safe.